Translating curve, so let's just recap the bits we've seen. So you'll recall with a horizontal shift, so we replace the x with x minus h. So y equals function x minus h would mean we're moving it, depending on whether h is positive or negative, moving it to the left or the right h units. And if you're ever unsure, think about where you're moving the origin to, and to do that, you solve the x minus h equals 0, and that tells you where the origin has been moved to. Vertically, similar thing, replace the y with y minus k. So technically it's y minus k equals function x, but normally we see it written something like that, y equals function x plus k. And so that will move it up or down k units again, depending on whether it's positive or negative. And again, if you're unsure of the shift, solve the y minus k equals 0 and it'll tell you where you've moved the origin to. So okay, here's x minus 3 all squared plus 4. So we've completed the square on our quadratic and come up with this. Now, hopefully we can just look at that and read off and go, oh yeah, I know where the vertex has gone to. But if we think of it with the idea of shifting, we say, well, all right, we must have started with our basic curve y equals x squared. Then, grouped with the x tells me the horizontal movement. So that's telling me I've shifted right 3 units, because x minus 3 equals 0 would give me x equals 3. So we've moved that over to 3. Then, the plus 4 there, or thinking in another way, y minus 4 when I group it with the y, if I solve that equals to 0, I'll get positive 4, so I must have shifted it up 4 units. So there's our new shape. Vertex goes to 3, 4, and so on. Second example, I know it's going to be a circle, because both the x and the y are squared, they're the highest powers, and the coefficients are the same. If the coefficients were different, we'd have an ellipse. So I need to complete the square first to get an idea of what's happening with this circle. So I get x plus 1 squared, half the coefficient of x. Y minus 2 squared, again, half the coefficient of y, so we get negative 2. That will create some extra constants. 1 squared is 1, negative 2 squared is 4. So I add that to the other side, we end up with 9. So when it's in that form now, I can see what's happening to my circle. So the basic circle is x squared plus y squared equals 9. Grouped with the x tells me the horizontal shift. So it's been moved to the left to negative 1. And then vertically grouped with the y, so that's gone to positive 2. So my centre's moved up to 1, 2. Y equals 2x squared plus 8x plus 5. Well, I'm going to divide everything by 2 here. So I've got it as x squared, and then I can play around with it a bit. Basically, also, if you want to complete the square, it's a lot easier to complete the square of x squared than it is 2x squared. So I always like to make that coefficient of x squared 1. So then playing with that, but that's created a 4. Now, once I've got that, y over 2 equals x plus 2 squared minus 3 on 2. Now I'll multiply back the 2, so I've got it as y equals, and then I can see what's happening. So y equals 2, x plus 2 all squared, minus 3. So our basic curve, y equals x squared, we know this curve will get steeper because we've multiplied by 2. So let's make it a bit steeper. Then we're shifting this one down 3. So there's our new parabola. We also looked at this idea of reflecting curves. So there's translation and there's reflection. So a vertical reflection, replace the x with negative x. So y equals function negative x will reflect in the y-axis. So flips vertically. If you want to reflect it in a different line, you can. If it was x equals a you were reflecting it in, then you replace x with 2a minus x. Let me show you. There's y equals function x. Function negative x, there it is, the red one, reflected in the y-axis. If I was to then shift that, so over to 2a, and the question is, what would make that equal to 0? So it would be 2a minus x would equal 0 on that one. And there it is. And you'll notice the reflection is in the line equals a. So that's why we need to shift it to a, not just a. to get the reflection at x equals a. Horizontally, well, this time replace the y with negative y, so it's the y this time. So we'd have negative y equals function x. Again, we don't usually write it that way. We normally see it as y equals negative function x, but technically, again, that negative is grouped with the y. That will reflect in the x-axis, but similarly to the last one, if I wanted to reflect in a different line, so y equals a, I'd replace the y with 2a minus y. So we'd have y equals 2a minus function x. And there's y equals function x, just to prove it. The negative function x would reflect it in the x-axis, shift it up 2 units, and hopefully we can see there's our 2a minus function x, but that's a reflection in y equals a. So similar idea. You could also reflect in the origin. If you hang on, reflect about a point. Well, what we usually call that, we don't usually call that reflection though, we usually call that rotation. But that rotation of 180 degrees is called reflection in the origin. So that would be y equals minus function minus x. So you reflect both horizontally and vertically, you'd end up with a rotation. So it's like a composite function in a way. We're doing function negative x and then we're doing negative of that as well. But we do it all in one hit. So let's show an example. There's y equals function x. If I want to rotate this 180 degrees, reflections. So do it by reflections. We get there's y equals minus function x. Reflect in the y-axis. And then there's function, or negative function, negative x, now I reflect in the x-axis. Oh, I said that the other way around, sorry. The first one was reflected in the x-axis, the second one was reflected in the y-axis. But if you compare the first picture to the last picture, you can see, oh yeah, we've actually just rotated that shape 180 degrees. All right, so y equals minus x plus 1 cubed plus 2. How do we put this all together? Well, the basic curve is my very dodgy y equals x cubed there. Pretend that's smooth, okay? So what have we done to it? Well, I've got the minus outside the x plus 1 cubed, so that's like it's being grouped with the y, because I could get that negative sign and very easily put it to the other side. So that's going to be a reflection in the x-axis. So there we go, we'll do that. Now, where have I shifted? Well, grouped with the x, we have x plus 1. If I make that equal to 0, I get negative 1. So I must have shifted left 1. And now, our vertical one, if I was to move that plus 2 to the other side, I'd get negative 2. Either way, however you want to think about it, but we've shifted it up 2 units. So there's our new curve. Y equals minus 2 to the power of minus x. There's y equals 2 to the power of x. This one's going to reflect in the origin, because notice we have a minus on the x and a minus with the y as well. So that's just rotation, 180 degrees. Whoop, there we go. So we can do the 2 things in one if you like. We rotate it 180 degrees. Okay, so 3G is on those type of translations and reflections.